overlooking the realities, we were unduly optimistic to begin with, and we just kept on going with that optimism, even though if we had known in the beginning what really had to be solved, I don't suppose we would actually have started.
That was the catalyst that would lead Dr. Philip Hill and his team to transform the future of diesel engines. Together, their new technology would allow diesel engines to run on clean-burning natural gas or methane, making the wheels turn on these workhorses of the transportation industry. High-pressure direct injection allows diesel engines to operate with the same power and efficiency that they are known for, but with a fraction of the emissions of smog-forming nitrogen oxides and particulate matter, not to mention greenhouse gases. But perhaps their biggest challenge wasn't in finding a way to burn natural gas in an engine meant for diesel. It was to do it in a way that matched the efficiency, torque, and durability of a standard diesel engine. The key, as he discovered, was to inject the fuel under very high pressure, and it was there where his breakthrough technology finally found traction with the advent of Westport, one of Canada's fastest-growing companies and worldwide leader in HPDI technology. Dr. Philip Hill is the 2011 recipient of the $100,000 Encana Principal Award.
What we're looking at is the way in which a conventional diesel engine is modified in order to supply natural gas fueling. But the heart of the matter is the set of fuel injectors which are placed inside the engine. We can see that in a little bit more detail if we turn over here, where we see the HPDI, the high-pressure direct injection injector tip assembly, consisting of two concentric needles. The inner one lifts first, and that supplies the pilot spray, and it's the products of combustion of that pilot spray that ignite the main gas, which comes in later through lifting of the gas needle, the outer concentric needle. And we can see how the actual configuration of the injectors is located here in this cutaway of an ISX Cummins engine. First of all, the gas supply is through this little manifold right here, this line, and the diesel supply for the pilot comes from that line there, and the next line is a return line for the excess diesel that is used for actuation to flow back into the cylinder. And the actuation of the two valves is, first of all, is a solenoid here for natural gas and also for the diesel. And so within this unit here are mounted the concentric needles that we've discussed already. And the challenging task in manufacturing these is that they require micron-sized tolerances in order to get the proper action of the diesel injector. This is the configuration for the ISX engine, but the future tasks involve redesigning this system for a series of other heavy-duty engines, and that work is really underway at present. Though the diesel engine was a wonderful machine, it really needed cleaning up as far as emissions goes. And at the same time, we had to try and have a concept that preserved the fuel economy, the durability, and the cost effectiveness of this as a great prime mover. This cell is one of 9 sites on this campus for exploring in great detail the performance and the emissions of HPDI engines. And this engine is then put through its paces at a whole range of speeds and torques, and then with various adjustments of the control parameters to try and find out what is the best operating condition under each requirement. And then to an item of very great interest, in this bottom corner here we have the emissions, and they're measured in very dilute emissions. They're measured in parts per million, and you have separate curves here for unburned methane gas, for unburned hydrocarbons, for nitrogen oxides, and for CO. That is the main function of the test cell at this time, is to experimentally determine the optimum control of all these parameters to minimize emissions while retaining high efficiency. I think for a decade, maybe emissions was a primary driving motive or incentive for alternative fuels for diesels. But economic factors, I think, are a huge driving force right now, and particularly with the abundance of shale gas reserves being discovered and the economic advantages of domestically produced fuels. It's not as though natural gas is the only solution. It'll be part of the grand picture. and it'll be offering advantages economically as well as in emissions. I feel hugely grateful for being able to play a small part at the beginning of what's turned out to be a fascinating venture. It's been an eye-opener to me how people of wonderful talents can come together, trust each other, and work cooperatively, not worrying about who gets the credit, but just being focused on the job and getting it done and seeing progress. That's been fun to see.